Hi everyone, in this video we're going to take a selective look at the history of women in science and engineering from Hypatia to modern pioneers. So I want to emphasize the word selective. What do I mean by that? We're going to selectively pay attention to certain facts and patterns, specifically to understand why women were able to participate and when they were excluded, and how institutions shaped whose work counted as real science or engineering. So let's look at the Hypatia of Alexandria around the 4th and 5th century. Hypatia was a mathematician, an astronomer, and a philosopher. And what's important about her is not just she was a woman in STEM, but when she lived. Okay, she existed before modern universities, formal scientific journals, professional societies. Knowledge at that time was produced through teaching, studying, commentary, community scholarship. And women could participate more easily because the gatekeeping institutions hadn't fully formed yet. So Hypatia shows us something very critical. Women's exclusion from STEM is not timeless. It is institutional because institutions weren't fully formed. There were minimum gender biases in science fields. Now let's look at the rise of institutions and the closing doors. Then as science and engineering became more formalized, institutionalized, like universities, labs, journals, patents, they began to close their doors, their access to women. Women were increasingly barred from universities, excluded from professional societies, denied authorship or formal credit, and instead women often worked as calculators, translators, assistants, technical collaborators. And then let's look at the Industrial Revolution. During the Industrial Revolution, and especially World War I and II, something interesting happened. Because of labor shortages due to the wars, women are recruited into engineering, computing, and scientific roles. So they performed highly technical work. They proved competence again and again. But after the wars ended, we went back to where we started. Men returned. Women were pushed back out. Their contributions were framed as temporary or just supportive roles. So this pattern, seeing this pattern matters a lot because it shows us women's inclusion has often been treated as conditional. It's not like a permanent inclusion, but like a conditional inclusion, which I find this pattern very interesting and note mentioning. So now let's look at the 20th century. In the 20th century, more women entered STEM fields, but often under constrained conditions. Like common patterns include limited access to leadership roles, right? Reduced credit for collaborative work, reduced recognition, teaching and service valued less than research, and higher standards applied to women's work. This is where concepts like Matilda Effect emerge. Matilda Effect is a big bias against acknowledging the achievement of women scientists and inventors and whose work is consistently attributed to their male colleagues. Wikipedia definition describes this very well. This is a bias against acknowledging the achievement of women scientists and engineers. Okay, so now let's look at today, right? Today we see women leading in computing, engineering, AI, biomedical sciences. This is a real progress. This is very good progress. It's great to see so many CEOs, tech leaders, pioneer engineers, top scientists. But here's the critical point. Even today, their work is more likely to be questioned, under-cited, framed as exceptional rather than expected, anticipated. So to summarize, what does this selective history tell us? We just looked at super quick, brief glances of important parts of the history, right? Women have always contributed to STEM, but exclusion is largely a product of institutions, like universities, labs, journals, not their ability or talent, or not about hard work of women. It's about the product of institutions. So history almost like filtered whose work becomes knowledge, hence the Matilda effect.